So, let's get this party started here. This is an example. These are the ones that were the most on the non-graphing calculator review. Here's the problems that caused the most trouble. So one of them was graphing a piecewise function. I understand, that's a little bit strange, graphing a piecewise function. Let's go back through this again. And the way I want to do this, let's first talk about how we can just graph this from scratch. And then we'll maybe look at some shortcuts for just identifying the graph. But I want you to know how to graph this. Okay? So here's the piecewise function. If I wanted to quickly sketch a graph of this thing, what are the key ingredients of this graph? Like, what are some things up here that are really important about this piecewise function? Somebody tell me something important about this. Yes? The breaking point. What's the breaking point? Negative 1. Aha. Okay, so if I'm going to graph this guy, the breaking point is at negative 1, so that's going to be right there, right? So there's my breaking point. Now, to the left of that, I'm going to graph one line, and to the right of that, I'm going to graph a different line. What's the graph that I'm going to put on the left of the breaking point, based on the domains? On the left of the breaking point. Look at the domains up here. There's my negative 1. How come the top one, Jacob? You're right. Less than. Yeah, less than means left of on a number line, right? So this is the guy, we'll make him blue. He's the one that's going to go on this side. We'll graph the line y equals negative x plus 4, right? On the other side, we're going to graph the line y equals 2x plus 7, right? And that's all I got to do. That's it. So let's go over to this side here. If I want to graph a line, all I need to graph a line are 2 points, and then I just connect and extend. That's it. Just remember that. That's the formula for graphing a line. There are many different ways to get those 2 points. You just pick the one that works the best for you or that works the best for the situation. Now on the right side, it's really simple because the y-axis is actually included to the right of the breaking point. So if I wanted to graph this line, the red line, what would probably be the easiest way to do that? Where's my point? My first point? 7. Yeah, I can see that this is in mx plus b form, right? And so the y-intercept is 7, right? So if b equals 7, that's an easy one. I'll go up the y-axis to y equals 7, and I'll make a point. And then to get my second point, that's really easy. What do I do to get the second point? Well, yeah, I'm going to connect and extend, but to get the second point, I got one of them is at my y-intercept. How can I really easily get a second point? Up 2 over 1. I'll use the slope, right? I know that the slope is 2, which is the same as 2 over 1. So I'll just rise by 2 and run by 1. And that puts me about there-ish. And so there's my line, right? Now, if I run that backwards, I'm going to go down to, what kind of an endpoint do I put on that? Is it going to be solid or open? It's going to be open, isn't it? Right, because I'm not including an equal sign. So I'm going to go back down here, and I've got an open dot there. Right. Make sense?
Wait,
How did I get what?
Because of the derivative.
Yeah.
Yeah.
I mean,
know that.
less than sign.
I know why it's open. I'm just saying, like, why is it that?
Well, if I want to find the exact point, I could find that. I could just make a little t-table, and I'm plugging in a value of negative 1 for x into my equation. So if I plug negative 1 up there for x, don't I just get 5 for my y value, right? And so there's my ordered pair. So negative 1, 1, 2, 3, 4, 5. So I mean, my graph's a little bit off. You get the idea, right?
So you just do never mind.
Okay, so I got my 2 points. No, they're good questions. I got my 2 points, and I just connected and extended. I'm only going to graph it to the right of the breaking point, and at the breaking point, I have an open endpoint because of the greater than sign, not a greater than or equal to. Right? On the other side, now on the other side, it's not quite as convenient because the y-axis is not included, right? And so when I want to pick my 2 points, let's pick 2 other points, other than the y-intercept as being one of those, right? We'll just make a t-table. So if I make my t-table, you can pick any x value you want and just plug it into the function and get back a y value, and that's going to give me a point, right? So, I don't know, what about -3? If I plug -3 in for x, what do I get for y? 7. Minus -3 is +3, plus 4 is 7. Okay, so there's a point. So I can go back 3 and up 7. 1, 2, that was what, right there. Okay, so right about there-ish. Okay. Now if I want to get a second point, did I mess that up? Oh, I went too far, didn't I? Whoops. So 1, 2, 3, 7, right about there. Okay. Now if I want to get a second point, I could put another point in my t-table, that's fine, or I could just use the slope, right? If the slope, what's the slope of this line? -1, so I'll just drop down by 1 and over by 1, and that's going to get me another point, right? And so I'll just connect and extend until I hit the breaking point at least, right? And what kind of endpoint do I get? Closed. So there's my graph, right? Now, you guys even have an easier task here, though, because all you have to do is identify the graph, right? So if I was looking for the kind of the fingerprints of that graph, the parts that make it easy to identify, you already told me one of them. One of them was the breaking point. I'm just going to look for the graphs with a breaking point of -1, and then of those graphs, I want to find the ones that have the right characteristics. On the right side, I should have a slope of 2. On the left side, I should have a slope of -1. If I need to check a point, that's fine. I can check the y-intercept over here, right? If I want to check a point over here, I could put an x value into this equation, find the y value, and see if that point is on the graph, right? So by process of elimination, I can make that process pretty simple. If I pull up, just to illustrate what I mean, if I pull up the graphs, right, so that's going to be, what's behind here? There we go. So if I want to find that one, okay, I'm looking for a breaking point of -1. It looks, now there's a breaking point of -1 right there. Right, everybody see that? I mean, can you see that, or is that, it's not very big, is it? No, that's fine. You can see it? Okay, so here I got a breaking point of -1. On the right side, it looks like I do have a slope of 2. On the left side, I have a slope of -1, right? I could check some points if I want to, but that's it, isn't it?
Does it have to go up?
Does the these have, what do you mean?
Well, I mean, like, there's a breaking point.
Okay, yeah, you're right. Okay, this is a different one, though. Here's a breaking point of -1, but the slopes are wrong. No, these are good questions. Because we have to identify, now, these things are set up so you can't just pick the breaking point. You have to also look at the other parts of it. This has the right breaking point, but the wrong slopes. On the right side of the equation, for example, the slope is -1. On the left side, the slope is +2, so they're mixed up. They're backwards, right? We didn't want that. We wanted ours to be instead. On the right side, the slope needed to be +2, and on the left side, the slope needed to be -1. So the other one didn't fit. Okay? Okay. All right.
You said that test was the following Tuesday after Thanksgiving.
Yes. Yes, that's what we'll do. Okay, what about these? Now, these absolute value ones, it's been a while since we talked about them, but yeah, these are not bad, right? Now, what you got to know on these, what really helps is you got to know what the standard form is, though, because that's what we always compare it to, right? So what's the absolute value, or the standard form for an absolute value equation? Y equals what? what's my standard form? Y equals A, good, times the absolute value of x minus h plus k. Very good. Okay. Now, all we ever have to do on these is we just have to compare the absolute value function to that standard form in order to identify what are the values of those three parameters, A, H, and K. Once I know those, the graph is really easy to sketch. Very simple. It's always going to be a V, and these tell us how to sketch the V. So if I compare, here I've got y equals the absolute value of x plus 4. So what values would I have to plug in for A, H, and K? What's A going to be? 1. Yeah, we know A is 1. What's H?
1 or 0.
Okay, it can be 0, isn't it? Because look, if it doesn't show up, then it must be 0, right? X minus what is the same as x? X minus 0. What about K? Positive 4.
Why wouldn't it be
Good.
1 too?
Say it again.
Why wouldn't it be 1 as well?
Because if it were 1, if H were 1, then that would have been x minus 1. Now, I understand where that question's coming from though. Because sometimes when something doesn't show up, we know it's a 1, and sometimes we know it's a 0. What's the difference? Well, look here. The A we knew was a 1 because it was being multiplied.
Yeah.
So if the parameter is something that's being multiplied and it doesn't show up, it's automatically a 1, right? Because 1 times something stays the same. If it's being added or subtracted and it doesn't show up, it's got to be a 0. Because adding or subtracting 0 doesn't change it, okay? So this tells us some important stuff then. Once we know H and K, that tells us the coordinates of the vertex, the point of the V. So it's going to be at 0, 4. And remember what A tells us. It tells us the slope of the right side of the V. So sketching this is really simple. All we do is we go to the point 0, 4. Go to the point 0, 4, right? And then when I want to graph the right side of the V, so there's my fold in the paper, right? That's the axis of symmetry of the V. On the right side, my slope is 1, so I'm just going to go up 1 and over 1. Up 1 over 1. And there's the right side of the V. So when I fold it over, what's the left side going to look like? Right? There it is.
So left side would be up 1.
Yep. Well, it's going to be up 1 and back 1 instead of over 1. Okay? Make sense?
Sure.
Okay? So that's what we have to find on the graph. Now, these can get a little tougher. What if I have one like this? It looks a lot harder, but I would argue it's really not. It's not that big a deal. I'm just going to do the same process. I'm just going to find A and H and K. Okay, it looks bad, but it's not. It's not. Remember, we're just going to compare that to y equals A times the absolute value of x minus h plus k. So we have negative 7 halves times the absolute value of x plus 3 halves minus 5, right? So what's A?
Negative 7 halves.
Negative 7 halves. Good. What's H? Now you got to be careful with this one. Good. It's negative. Negative 3 halves, right? Always going to be, because we're subtracting the H, it's always going to be the opposite of the operation after the X, isn't it? Right? So if it's X plus, you know that H is negative. And finally, what's K?
Negative 5.
Negative 5. So this tells us the vertex is located at negative 1.5, negative 5, right? And the slope of the right side is going to be a steep negative slope. So the V is pointing down and it's a steep V, right? So it would look like this. So I'm going to go back 1.5, and I'm going to go down 1, 2, 3, 4, 5. So right there's my vertex, right? And then there's my fold in the paper. I'm I'm gonna go from the vertex, I'm gonna go down 1, 2, 3, 4, 5, 6, 7. And I'm gonna go over 2, which puts me right there. If I started at -1.5 and I go up 2, I'm gonna be at +1/2, right? So there's my 2 points. Using my slope triangle. There's the right side of the V. So the left side will just look like that. Right?
Yeah.
Okay, so now let's find that graph.
What'd you do?
I don't know what I did. I have no idea. There we go. Okay, so if I go down here, now notice these are all the piecewise functions. Below those are the V's. So those are the absolute value functions. So that's actually it right there, isn't it? Right?
That's it.
That's it. Now we can check. Look where the vertex is. It's at -1.5, -3/2, -5. Right? It's just that the window's been changed so we can see it more easily. And then if I look at the slope here, the slope, it's going down 7, 1, 2, 3, 4, 5, 6, 7, and over 2. There's my -7 + 2, so that fits. Yes? Yeah. Yeah. If it were a negative, then, okay, on the problem, right. So, question is, what if it had been a -3/2? If it had been a -3/2, then H would have been +3/2, right? And so we would have gone over instead of back 1.5. Okay? Okay, does that make sense? Okay? All right, these.
Oh my lord.
Okay, now, once again, I think
Yeah.
these look harder, but they're way easier. These are the easiest piecewise functions. They really are. What? And here's why. They're simple because the lines that you're graphing are so easy. Look at the y equals what? Y equals -1, y equals -3, y equals -5. I'm always getting y equals a number. If I have y equals a number, what does the graph look like? Yeah, just a horizontal line, right? It was something very much like it was, yeah. 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 Right? And so they're all horizontal lines. So if I graph this thing, I want you to just see how easy this is. And there's a way, I think, if you're having trouble with these, pay very close attention to this. Because I think there's a way I can make this real clear. I think if you're having trouble, I think I know what your trouble is, and this should address it. So let's see, I want to do this. Okay, so now I'm going to graph 5 different pieces to this thing, right? Let's graph one of these. Let's start off just graphing the top piece in red. So what about this guy? Okay, what that's telling me is I'm graphing the line y equals -1 on the interval x is greater than or equal to 0 and less than 1, right? Okay, so let's graph the line y equals -1. The line y equals -1 just looks like this, right? Agreed?
Yeah.
Okay, so there's the line. Y equals -1. But look at the interval on which I'm graphing it. We're graphing it when x is greater than or equal to 0 and less than 1. So I'm going to put endpoints to my segment at 0 and 1. Which kind of an endpoint do I put at x equals 0? Closed. So I'm going to, there's one endpoint that's closed. At x equals 1, I'm going to get an open endpoint. And so from that whole graph of that horizontal line, the only piece that I'm actually graphing in my piecewise function is that little dash, that little segment. Does that make sense? Okay. Let's go down and look at the next one. So if I look at this guy right here, he'll be blue. That's just going to be the line y equals -3 on the interval where x is greater than or equal to 1 and less than 2. So if I graph that horizontal line, there's -1, 2, 3. That one is just going to be a horizontal line through -3, right? But the only small piece of that that I graph is that piece right there, right? So I got a closed, if there are phones and stuff out, please put those away. This would be a real bad time for that. So I'm going to get a closed endpoint at -1, or excuse me, at +1, open endpoint at x equals 2, and that's the little tiny segment that I'm graphing of that horizontal line. See how that works? Okay? And then I would just keep going down. I go to -5, that's down here. I'm only going to graph the piece from 2 to 3, and then go down to -7, and that's getting graphed from 3 to 4, and then -9 gets graphed from 4 to 5. So it looks something like that, right? Okay? Make sense? Okay.
Ooh, a star.
A star, how about that? Okay, so now these are really, I'm going to take just a brief second and do this. This is really simple. I mean, but while we're here, how do we graph a line? Very simple. If I want to graph a line, remember, just 2 points. Just got to connect and extend 2 points. So my 2 points on this one are what? Okay, good. Y-intercept is at 1. So I get a point there. My y-intercept. How do I get my second point? Yeah. Slope is 4 over 1, right? So I'm going to rise by 4 and run by 1. Okay? Right? That's it. Okay, what about... Okay, now what if I have one like this? What if I had the line 2x minus 3y equals 6? I want to remind you about that little trick, that little cover-up trick.
Thing.
Yeah, the 0 thing, good. So if I want to graph this one, all I have to do is find the intercepts. Very simple to do. If we're starting with an equation that's in standard form like this, you know, ax plus by equals c, where it's not solved for y, then I can just let x equals 0 to find the y-intercept, so I cover up the x term and solve for y. What do I get? Tyler, is your phone out back there?
Yeah.
Okay, put that away. You need to be watching that. So -3y equals 6. What's y equal to? -2. Okay, good. So we're going to get one intercept is going to be at y equals, the y-intercept is at y is -2. Cover up y and solve for x. We get the x-intercept. 3. So we just go over 1, 2, 3. There it is.
Whoa.
Escape, right?
Isn't it
Say it again.
oh wait, the court,
Make sense? Now, but look what happens. Here's one of the very few cases where that doesn't work, because if I cover up x and solve for y, I get 0. If I cover up y and solve for x, I get 0. So both of the intercepts overlap this time at the origin, right? And so that's not going to work. Instead, I can always just solve for y and simplify, and that means putting it in mx plus b form. Right, PJ? Right? Okay. So what would I do to get that y by itself?
Subtract 2x.
Subtract 2x. And I get y equals -2x, right? Y-intercept of 0, slope of -2, done. Yep. Okay. Good. All right. Moving on. Very simple. If I get an x equals a number, what kind of line is that? You did this. That's not horizontal. That's vertical. Yeah. Because it's cutting cutting through the x-axis at that x-intercept, right? If you're lying down, maybe. Anyway, so it's a vertical line through x equals -5. Okay, what about this one? Okay, these kind, all you're going to do with these is you're just going to extract the information from the graph and plug it in. We just need M and B, right? Now, lots of times, this is a convenient one because we can see both M and B just by inspecting the graph. We can see those. What's B this time? Yeah, it's crossing at 1, isn't it? Right? So we can see right there, B equals 1. If I want to calculate M, all I have to do is make a slope triangle. So I could just go up 1 and over 1, or I could go like up 5 and over 5 if I wanted to. Either way, the ratio is just 1, isn't it? Right? So M is 1. And so my equation of the line is just y equals 1, x plus 1, which I would just write x plus 1. Okay. Now, worst case scenario, let's say that the line doesn't pass through a convenient y-intercept. It passes through at some fractional y-intercept. What do you do then? Don't panic. It's not a big deal. All we have to do if I need to solve for B, what do I have to do to the slope-intercept form of the equation? To solve for B, what do I have to do to the rest of this stuff? Plug in values, right? So all I would have to do in this case is just find the slope from the graph, plug that in for M, and then find a convenient point on the line. It doesn't have to be the y-intercept, but any place where the line passes through a convenient point, and the coordinates of that point are just x and y, right? Plug them in, solve for B, right? That's the worst case scenario. Usually you can just spot B. Okay, these. There are lots of these, and these, they look daunting. There are lots of words there, but they're all the same question. They essentially are always giving you some information about a point and a slope, and you've got to turn that into either just a slope, which is easy, or maybe a little tougher, solving for B. Now in this one, read these carefully, because I think sometimes people miss these because they just jump to assumptions about the question. They didn't read it carefully. A line's passing through this point, and it's perpendicular to the line, this line right here. Now all they want in this case is M, the value of the slope of your line. So we don't even need to find B. If our line is perpendicular to this one, and the slope of this line is what? -11/5, good. So then, Travis, what's our slope going to be? Okay, well, pay attention. So what do we got here? If this is the slope of the other line, and ours is perpendicular to that, what should the slope be? Opposite reciprocal, right? So we flip it and change the sign. There it is. Okay, done. It wants a decimal, so I just put that in the calculator and get a decimal. Okay, what about this one? This is a little harder. This time they've got a line passing through the point 219. It's perpendicular to the line passing through these points, and this time they want us to find B. So what do we do?
Slope of
Good. Okay, good. So we need a slope. So we'll take this point. Well, hang on. We'll take these points right here. There we go. So I got these 2 points. I need to find the slope of the line through those 2 points. So.
Right? Is that?
yeah, y2 minus 5.
Yep. What's that going to give us? Okay, so here 9 minus 2 over 9 minus 8. Or I could say 2 minus 9 over 8 minus 9. Doesn't matter. Either way, I'm going to get the same answer.
Wait.
7 over 1. You like it better the other way?
I guess so.
Okay, I think.
I think I'm confused because I thought it was Y2.
Okay, it is. It is. Here's where the confusion comes in. Which point am I calling x1, y1, and which one am I calling x2, y2? It doesn't matter.
You'll get the same answer.
It gets the same answer. All you have to do is be consistent. I have to either subtract the left values from the right values both times, or the right values from the left values. I have to just do the same thing both times. In this case, the reason I did this is so I get positive numbers. Right, so I just subtracted 9 minus 2 and 9 minus 8, so they'd both be positive instead of having them both be negative. Either way, I get the same answer.
Okay.
I get the answer of 7 over 1. Okay, so that's my slope. But we want the perpendicular slope. So what's the perpendicular slope going to be then? Negative 1, 7. Yeah, good. So perpendicular slope is negative 1, 7. Now, if I want to find B, what's my strategy for solving for B?
Plug in the numbers.
Yeah, plug in the numbers. I'm going to go to the...
Couldn't you just like have like if it's 7 over 1, isn't that closer to this 7? And then you just have negative 7.
It's the opposite reciprocal.
I know. I was just asking like, isn't 7? Mine.
Are you sure?
Yeah.
Okay. Okay, so last step. And if we get through this one, this is pretty good. The last step here is we want to solve for B by plugging in all the other stuff, right? So we know that we have negative 1/7 gets plugged in for M. What do we plug in for X and Y?
The point that cat.
Yeah, 2 and 19. We have to pick the coordinates of a point that's on our line, right? These other points won't work because that's a different line, but the 219 works. So I'm going to plug in 19 for Y and 2 for X, right?
Right.
Okay, and that's it. So we get 19 equals negative 1/7 times 2 plus B. So here's when I plug the stuff in, right? All I got to do is solve for B. Now here's where the calculators are very handy. We can do this right into our calculator. Now watch this. If I want to solve for B, all I've got to do is just get this fraction to the other side. Now what am I going to get from that fraction if I multiply negative 1/7 times 2 over 1? Good, negative 2/7. So I get 19 equals negative 2/7 plus B. So to get B by itself, what am I going to do? Yeah, add 2/7 to 19. So in my calculator, I'll just do 19 plus, now how do I get the 2/7 in there? There's two easy ways to do this. You can if you want to. People seem to like this template, and it's fine. If you want to use the fraction template, just alpha F1, enter, and I get my little fraction template. So I can add 2 over 7. Right? Well, I have a negative on this side, so I'm adding, right? Adding 2/7. Make sense? What's that? Yeah, okay, but if I press enter, watch what happens. It's going to give me back a fractional answer. So if I use the fraction template, it assumes I want a fraction back, which is fine. To get a decimal, I just go math 2, convert to decimal. There it is. Now, to me, a much easier way to do that is just to say 19 plus, here's the trick. The quick trick for dealing with fractions is, on a calculator, if you just always enclose the fractions in parentheses, the calculator just treats them like numbers, like decimals. So I can just do that, right? 19 plus 2/7, enter, got it. Okay? I don't really need to go through and add these fractions up. I just want a decimal answer anyway. Just plug it in my calculator. Okay? Make sense?
Yep. Yeah.
All right. Probably a good place to stop.